1 kilowatt inverter connected to a solar panel. That combination makes an off-grid system. What if we couple that with the grid supply? That is why we have this AVS connection, meaning that we are feeding our system with that. That definitely is a very important connection. But again, we also have the battery, and for demonstration, we will be using this battery right here. It is a 12 volt 200 amp hour battery. All right, so we will be demonstrating how to connect the inverter. Of our main interest definitely is this inverter from mast. So stick around as we will be guiding you through. One important thing that we need to highlight as well is the tools as well as the instruments that we'll be using. Why is a digital multimeter important? Of course, because when we talk about solar installation, when you talk about a battery, we have DC, so we will definitely be recording the direct current. Also, the output from the inverter is AC, so that is why we will need that. And of course, the tools, my top boss, this is what we'll be using for tests. We also need to record current, both direct current as well as alternating current. We have our clamp meter right here. We also have a non-contact tester, and for stripping we require that tool. My top boss, if you have ever installed a 1 kilowatt inverter, let me know in the comments section. Be it with the manual inverter or with this inverter right here, my top bosses. And if you are ready for this value, my top boss, smash the like button. And even if you are not subscribed, subscribe so that you don't miss any of the videos that we share. So my top bosses, to begin with, it is important for us to first of all highlight the important safety precautions. Before you can work on an inverter, always ensure that it is off, because it can have excessive charges on the surface which can definitely harm you. So for us to start, we'll ensure that the AC is switched off, and that is what we are going to do. And in 3, 2, 1, that is what we have. So the inverter is off, and we'll also switch it off, and the inverter is off right there. We will also be disconnecting the battery so that we are very sure that we don't have power going all the way to our inverter right there. Connection or the wiring of an inverter, we need to understand that we do have important features for the inverter. And the important features is that it has the AC connection and the DC. What is AC in full, top bosses? What is AC in full? And also, what is DC in full? What is the difference between the two? So now, my top boss, we have the PV connection, and what we do have right here is the cables from the PV as well as the cable from the battery. So the battery cables, as you can see, they are thick in size, or we might say the cross-sectional area is wider. If my assistant can come closer and just look at what we have right here. So these are the cables going all the way to the battery. So let me just bring the cables closer. We have blue going to the positive connection or the positive terminal of the battery. Here we play with some few terms, instead of saying the live, we use the positive. All right, so this one goes to the positive, and the black goes all the way to the negative connection or the negative terminal of our battery. Now, my top boss, with the absence of the AC, we are good to go. Now, we need to isolate, or we need to remove the case or the cover of the inverter. So if my assistant can come closer, and together we should go through the caution. There is a caution that is right here. This caution uh, guides us on how to deal with the inverter, my top bosses. As you can see, the first caution is for operation: read user manual. Very important. You have to read the user manual. This unit must be opened by authorized technicians only. Am I? I hope so. Keep children away from this machine. Makes a lot of sense because we need to be very careful. Now, I need a star screwdriver so that we can definitely open this cover. So why is it important to access this cover? Because for us to access the cable terminations, we definitely need to open the cover and see what is happening. So at this point, I'd like us to also unscrew this other screw that is right here. Remember, you need to be extra cautious when it comes to this connection right here. So my top boards, as you can see, a closer view, we have that connection, and we will be understanding how it is done. Thank you, Director Lee. So top bosses, if you have ever installed an inverter, you definitely are aware of these connections right here. So we have this fan and we also have this fan. The two fans are very, very important. They play a key role, and I'm about to explain to you how that goes. So my top boss, as I was talking about these two fans, of course you understand a very important aspect when it comes to inverters is that there is heating that happens when charging the battery, and also when a load is connected. You discover that when there is a load, these fans will definitely be activated. Now, when disconnecting an inverter from a battery, you start by disconnecting the PV, and therefore that is the reason why our PV is off. And for that, we definitely disconnect the PV. PV is photovoltaic. In other words, that is basically solar. Look at the cables that we have for PV. All right. So let's just make sure that we disconnect it completely from the inverter. When it comes to inverters, batteries, and solar, you also need to take care of one important aspect, which is definitely short circuit. If you short circuit the system, you will have a lot of challenges. So if this is the cable that comes all the way from the solar panel, you definitely need to make sure that it is not short circuited, and so you have to protect it. So every time you are working on that cable, be it the cable coming from the battery or be it the cable coming from the PV, you must ensure that you protect one of the connections or even both, right? Majority of the people have been using the wrong cable when it comes to solar, but the correct cable, as we have been saying, is definitely a cable where you can connect the earth connection, for instance this one, or you can also have the PV cables and have two cables, that is the red, the black, and you also have the earth connection. For instance, this one here, it has this part where you can connect the earthing. So basically you can connect to the body of the PV or the solar panels, and then you can have this connection to the positive PV, negative PV or photovoltaic. Another cable, if my assistant can help me with it, is definitely the PV cables which are black and red. I'd like to demonstrate to you something about these cables, and majority of the technicians are not using these cables right here. So these are basically the correct cables to use for solar connections. So this is what we have. We have the black and the red. If possible, ensure that they are all copper, pure copper, like the one that we do have right here. So you do have the copper, and we also do have the aluminum. And then for you to understand how these cables are also, I would like us to strip so that we can see the insulation, especially how the layers have been made. So if I demonstrate to you the various features of the insulation, wow, what an incredible camera that we do have here. Good job. Good job right there. So you can see it has several features. Very, very important to notice that the insulation is thicker, because we are in thicker, because there is a lot of temperatures or heat in the roof. Sorry. On the roof, there is a lot of temperatures. And also remember, these cables pass in the ceiling or through the ceiling, and therefore the temperatures are very high. So look at how thick that insulation is, my top boss. All right. So that is the recommended solar cable. Now, so the connection is at this point where we have the PV connection, both for positive and negative. Let us also disconnect the battery. And if my assistant can come closer and just zoom in at the battery connection at the inverter. And I don't know whether my director can help us with the lighting. Is the lighting sufficient at that point without the shadows? Thank you so much. Good job. If the lighting can come this side, nice. So this is the connection for batteries. Good job. The lighting is super awesome. Thank you so much, director. So we disconnect the black cable. We also disconnect the blue, which is for positive. So I want us to just disconnect everything before we can start connecting, and I will demonstrate to you how it is done. Remember, when disconnecting the inverter, you start disconnecting the PV. That is what we have done. When it comes to the load, you can start with any, but again, ensure that the AC is off, and even that means the incoming AC as well as the outgoing AC to the load. All right, the load or the connection for the appliances that we use, be it for lighting, be it for sound system, be it for TV. All right, so we have disconnected the AC, which is incoming. We've also disconnected the load, and so we want to isolate the inverter so that we start everything from scratch. So our inverter, as you can see, is not connected in any way, right? Not connected like that. So even this cable, let me just have it come all the way right here. Perfectly isolated. Thank you so much, my assistant, for the good job that you're doing. Top bosses, would you like to know who is the top boss behind the camera? Or as many top bosses will say, cameramani. It is our one and only Margaret, directing us, taking us through when it comes to lighting and also the angles of the camera is the one and only our director Lee, doing the most nowadays. Top bosses, we are a complete team doing the most. But again, I don't know whether you would like me to remove this cover so that you can also see the parts of the inverter. Would you want us to do that, top bosses? What do you think, Margaret? Can we do it? All right, so that we can get a clear picture of how the inverter looks like from inside. All right, so let me just remove the screws. If you can take a clear view of the entire inverter, it will be great, Margaret. The whole inverter, probably you require to lift your camera a bit high up. So let us have a clear picture of the inverter so that our director can also have a very good view and also get some good points when it comes to sharing more information. So those are the important features that we do have when it comes to the inverters. The inside of the inverter is not as sophisticated as many people may think. So that is basically how the inverter looks in the inside. Very important features right here, my top boss. In fact, if you thought that this cover here, this paper is useless, my friend, it is not. This ensures that all the air that is redirected by this fan or the air that is captured by these fans goes all the way in to these important features right here. What is this, my top boss? What are these aluminum-like features or items in the inverter? These are referred to as heat sinks. They are connected to MOSFETs, all right? So they normally overheat. So with heat sinks alone, those MOSFETs can actually overheat and be damaged or blow. So that is why there is a fan. The important feature that I highlighted, this nylon paper ensures that all the airflow is redirected, all right, to these very, very important features right here, which is actually uh, the heat sinks, all right? So you have the capacitors. We also have other parts. We also have multiple diodes. And another important thing is we have this connection from the main PCB connected to this display right here. So if we can just turn, you can see that this is a display that is connected to the main PCB. Do you have any questions, Margaret, from our top bosses? We don't have. All right. We also have several comments right there. I have a comment from our top boss, the one and the only Maga, says, top boss is on fire, lit. Jonathan is watching from Kenya. Thank you so much for watching. So for more features, we'll definitely be highlighting them. But today, I just want us to connect these 1 kilowatts inverter. All right, isn't it? Do you have any question? You okay? All right. Top bosses, it is always important to have a magnetic screwdriver so that you can simply attach this screw. It is a simple feature of an electrician's tool, but very, very important, helps you to work easily, and it also ensures that you don't lose the screws. Very, very important. Top bosses. Now, very important for us is to now connect this inverter to the load, to the PV or the solar panel or panels if you have several. And also another important thing is to connect it to the battery. We also connect it to the AC, the incoming AC, as well as the outgoing, meaning we connect it to the load. This is where safety plays a key role, and that is why I have to ensure that I am well protected against any injuries. I don't know whether these will protect against an electric shock. I'm not sure about it. But one thing that I'm sure is that I will not have minor injuries from working on the wires as well as these. Engineer? Dan. Welcome, Top Boss. Good to see you watching all the way from Narok. We also have another Top Boss. Who is that? The Jimbo. From Zambia, right? Now, you are very much welcome and thank you so much for tuning in from Kenya as well as Zambia is represented. Top bosses, for us to install this inverter for a customer, for a business, for a home, and for practical purposes, the first step is now to ensure that we connect the load. After the load, we connect the battery. And after the battery, we connect the PV or the solar panels. And finally, we connect the AC. Yes. But when disconnecting it, assuming you want to replace it with a new one, the first step is to start with the PV as well as the AC, isn't it? So that once the battery is disconnected, the inverter does not remain with heavy or high currents from either the solar panels or from the AC because it can damage it, right? The moment you connect a battery, all the components that, like we have seen, are set to work with the voltage, the battery voltage. If an inverter is supposed to be a 12 volt, that is what you ensure that you connect it, because if you connect anything higher, it will definitely damage it. So this one is our load. We connect the load, right? So the AC output, I don't know whether our assistant right here can be able to see those very tiny words, AC output. So this is the key feature, a key feature of the inverter. We have the AC. So if we can just try to, where is the AC? Right there. Good job. We have the AC output, we have the AC input. So at the AC input, that is where we feed the incoming from the national grid or from the consumer unit. The AC output is now the load that we connect our outgoing loads, be it the lights, be it the TV or the sound system, isn't it? Yeah. Nice. So the next step is to connect the load. Allow me to connect the load, which in this sense is the AC output. The AC output, for us here, we will simply connect a lighter load, which is this one, feeding a light output. Remember, the AC output and the input have one earth connection to the inverter, as you have already seen. So they share. The output, the input share the earth connection. All right. So let us connect the output. I'll still be demonstrating to you how we have done that in a close-up video. So this is how you wire the output to the load, connect it at the AC output. So red, which I'm using here, connected to L, which is definitely line or live, as our friends from USA will refer to it as the line. So that is the line or the live. Yes. Mr. John, I've gone through a lot of videos and know how you have done wiring system using sheep. Sheep. All right. Coming up, we shall be sharing that video in our coming YouTube videos. So stick around. Right. Any other comment? No. All right. Yes. Abdallah is watching from Comoros. 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 Yeah. That is Abdallah. Yes. Where is that? Comoros. Hmm. Hmm? So the AC input, you have to connect properly the AC input. Top bosses on the charts, let me know. What if you make a mistake and connect the incoming AC on the output? What can happen to that inverter? Can there be an issue? What issue can happen if you connect the input to the output of the inverter? You kindly ask.
So our load is the AC.
AC, outgoing AC. AC output is the load from the inverter. Yeah.
Types of load.
Types of loads connected to 1 kilowatt, lighting, sound, TV. So what would happen if you connect, let's say, an iron box, which is consumes 1000 watts to a 1 kilowatt inverter? What will happen? It will shut down because that is an overcurrent.
1,000.
Yes,
And
1200 watts. That is excess of 1 kilowatt, which the inverter only provides. Yeah, can handle, right? So it will simply shut down to protect itself against damage. Yeah, that is the same way how an MCB behaves. A double pole MCB behaves in case there is an overcurrent. Yeah.
someone is saying,
Mhm.
or how many saying most has succeeded.
Top boss has succeeded. Thank you so much for wishing me success, Wahome. I really do appreciate that. We are very successful right here. So we now connect the neutral, which in this case is the blue connection. Yeah, blue. That is for single phase, but of course for three phase that would have been a phase, isn't it? I know that's the reason why our top boss Margaret is reacting. How comes? Yes. Yeah, for the battery, blue is positive, correct. I agree. Now, when I went to purchase the cables, I couldn't get red to match up positive connection. So that is why I have it in that color. But the right connection should be red. Red for positive, and then black for negative. Yeah. So now that we have connected the AC output, the AC input, it is now time. Almost said it is now my pleasure. It is now time for us to connect the battery. Again, remember, even if we have connected the AC, we have not connected the we have not fed the inverter yet. So you cannot feed the inverter in the absence of a battery, because those will be excess currents coming all the way to the inverter, which might damage this inverter. So the battery is the next connection after you have connected the load, and then you have connected the AC. Still the AC is absent from this connection right here. If someone were to switch on AC accidentally, our inverter is damaged. Now, before we connect PV, we then connect our battery. Look at the massive size of the cables. Yeah. Hmm? Yes, connection of the battery before the solar. Our load. AC. This. This is AC going to the loads, going to the bulbs. So you have connected that first before we can connect the AC. input. So this is the AC out.
It's out.
The inverter will give AC output, and it also has the incoming AC from the consumer unit, which is this. So this one. So from the consumer unit, it goes here, and then it is the output now is this one, is fed to the input. So the input to the inverter. But again, the inverter gives an output.
Really?
Yes. So that is the AC out. Yeah.
Hivyo tunaingia hapo tunakuja
Wapi hapa?
hapa.
No.
Tunaanzia
First,
hapo kwa AC. AC inaingia hapo kwanza.
Yeah.
Inaingia kwa inverter.
it comes here first,
Hapo.
then the output is this one, goes to the inverter, which is
Inverter
this
input.
one, the inverter input. And then yes.
Yes.
How many mm are those cable?
Which ones? This one, the blue and black, 25 mm. Remember, for lighting, this one is 1.5, goes for lighting. Yeah. For the batteries, it is 25. For the solar, it is 6, or I think 10. This one is 6. Yes, thank you, Margaret. This one is this one specifically is 6.0. You can see the size of the cable itself is bigger than what we are used to. It's like the AC 10 mm, isn't it, Margaret?
Yes.
But the cable itself, the wires, the copper wires are 6 mm. For the battery, pure copper, 25. So let us connect for the batteries. Common mistakes that people commit when it comes to inverter connection is that they reverse the polarity. That is the first common mistake committed by installers when installing inverters. So if you are installing the 1 kVA inverter or even more, ensure that the polarity is connected properly. So this is negative, or this is minus. I am connecting it to the DC minus. Okay, DC minus. So that is what we have right there. This is positive, goes directly to the battery positive. So we connect right there. Ensure that we insert all the way. That those cables must be lugged. Now, we will definitely be lugging them so that it is not just cables. So that is what we have. We'll lug it. So in the meantime, we will connect it for demonstration purposes. Don't try this at home, especially if you are not a licensed technician. This stream, as well as the videos that we create here at Top Heights Electricals and Electricians, are for general purposes only. Do not attempt to do this or implement it in your projects or at home or any person's business. We shall not be liable for any dangers that will emanate from these type of video lessons. So we have already connected the positive and the negative. Okay, so from there we want to connect the battery. If my director, before we even do that, we will be demonstrating how we do it on the battery. Just a minute. So these cables, we have the positive, which is blue, going here, and the negative, which is black, going all the way right there. So we go ahead and use these connections right here. And what we'll do is take the black cable to that. So we start with the black, and then we ensure that we tighten it before anything else. Before we connect the positive, remember we have to ensure that it is very, very tight. So that is what we do, so that when you connect the positive, we also ensure that we tighten it. In many cases, you find that when you place it right there, there will be a spark. So to avoid any injury, we ensure that connect it like so, hold it to the terminal, and then we can screw our bolt all the way down. So the first mistake that we have said is interchanging the connection. Positive, you connect to negative, and negative to positive. That definitely can damage the inverter. Another mistake that people commit when it comes to installation of an inverter is using undersized cables. For instance, if you decide to use very low size or very small sized cables, if you decide to use 2.5 for these battery cables, they will overheat. Why? Because the current exchange between the inverter and the battery is usually very high. You can see that we have a 12 volts battery, and the current that we are talking about here is 200 amp hours, right? So in 1 hour, this battery can give out 200 amperes. So that is a very high current. You must ensure that you are very keen. Now, my top boss mistake number 3 is using the wrong cables. For instance, I've been fighting a lot with many electricians whereby they prefer to use these cables, which are AC cables, instead of using these cables, which are referred to as PV cables. These are the correct cables to be connected from the solar panels to either the inverter or the charge controller. These are referred to as PV cables. These are referred to as AC cables. The reason why many electricians insist on connecting this one from the solar panels to the inverter or the charge controller is beyond my comprehension. You should not use these AC cables. Why? Because these cables are used to supply high volts at low currents. Whereas when we talk about DC, we are supplying high currents at low voltage. That is why you find that a solar panel which is rated 12 volts can actually be supplying 10 amperes, whereas a cable such as this one can be supplying 240 volts at one current, at 1 amperes of current only. So that is why we need to be very, very keen when it comes to selection of cables. Another mistake that people commit, which is number 4, is definitely when sizing up this system, they use the wrong voltage from the battery. If this is supposed to be a 12 volt inverter, don't connect a 24 volt inverter, because this inverter is indicated on the side. It is a 12 volt DC system, or the system voltage should be 12 VDC. That means 12 volt DC. And another mistake that people also commit, like we have said, is wrong connection. If you are supposed to start disconnecting the battery or start connecting, if you are supposed to start disconnect the PV, you do it the other way, and therefore it means that it will be damaged. Mistake number 5 is definitely overloading the inverter. If you overload it, you will definitely have issues. All right. So those are the 5 mistakes when it comes to inverter connections or solar power wiring. Top bosses, let us go ahead and connect these massive cables right here. I'm really, really fascinated by DC connections. So we will be connecting these to the battery, and then from there we can feed the PV. The moment we feed the PV, we shall switch on the inverter and you will see how it goes. Right? Let us go. We go ahead. Before we switch on the inverter, we connect the PV. Alternatively, we can also decide to switch it on. And my top bosses, we are back like we never left. Because you know what? We never left. We have never ever left. We were just here ensuring that this current right here, can you see the current flowing through these two conductors? So this is from the PV or from the solar panel. How can we prove that? Using our digital multimeter. So this is what we have right here, my top bosses. We will take these probes, and now we want to ensure that this is the negative, this is the positive. All right. How will we know that? We also want to test the voltage, which is definitely DC. So that is why we have our digital multimeter set to that. All right. So once we have it at that, we'll simply place our probes right here. So we have the positive, right here. You have the negative. What are we getting? 36. Is it positive or negative? Positive. So that is another way to check for polarity. Also, a different way to check for polarity is definitely, thank you so much. Another way to check for polarity is to take the probes and simply interchange like so. So you have that. It has to give us a negative. What are we getting? So negative 36.4, that indicates we have reversed. So leaving us with blue as the positive and black as the negative. What happens if we place the pointer at 20? We'll definitely get a -1, or we'll get a 1, meaning infinity. That is not the correct way to have it connected. Now, we will redirect what we have here, which is the cable from the PV or our solar panel right here to our inverter. Being careful to ensure that we have blue to PV plus and black to PV minus. So if my assistant can come closer and we record PV plus as well as PV AC, you can see we have DC minus DC plus, that is for the battery. We also have PV plus PV minus. What is PV in full, my top boss? Look at how incredible this inverter is built with the fans right there. My top boss, the following are features of a high quality inverter. It has the fans to ensure that it is cooled, number one. Number two, it has this display, and it has these buttons here to ensure that you can be able to program it properly. It also has many protective devices which are internal. All right. So it ensures that in case there is a short circuit, it will definitely trip, avoiding damage to the inverter. Another important feature is that it has these airways. So on the side, we have an airway right here, and we also have an airway right here. So when these fans blow air from this environment here, the air will go in, cool everything, and then the hot air will flow out through these outlets right here. Another important feature is that the body of the inverter is metallic, which ensures that the cooling of the internal features is fastened by simply dissipating the heat outside environment, because this is a good conductor of heat. So it ensures that there is maximum flow of heat from inside so that the components are not affected. All right. Okay. Now, moving on, my top bosses, now let us connect the PV. So like we said, we have the positive going to the positive. For us, blue is the positive, black is the negative. If we had connected this inverter to this wire right here, we will definitely be earthing this point. The solar panels need to be earthed, and we earth the body. You don't earth the neutral, my top bosses. After connecting the neutral to the neutral, the positive to the positive, you now connect this to the body, this aluminum part of the solar panel, and you earth it the correct way that we normally earth the electrical features. So in the meantime, this is what we are going to do. But if we are doing a rail installation, we will definitely use that extra cable for earthing, my top boss. Again, remember I said that this is a video for demonstration purposes only. Do not conduct this work if you are not a qualified technician. So we will insert it right there. And once the inverter senses that the solar is connected in, even in the off position, it will switch itself on because it will indicate that it has prioritized solar. That is why the inverter is on. So the continuous sound indicates that there is an error. Let me disconnect it first. So from the inverter screen, what you see is a solar panel. There is a sun emoji, if we can go by that because of the current times. We have that. We have the panel indication right there. We have the battery, it is charging. The fault is an indication that the battery is not fully charged, all right? And so it's not supposed to be operational, and that is why we don't have the output. You can see this is an indication for inverter. This is the battery, and this is the solar panel, right? So DC from the panel to the inverter gives a DC out to feed the battery, so that is why it is charging. If the panels were sufficient and the current was sufficient, it will charge the battery to the point where we'll also get an output to the load. That is what will indicate an output to AC loads. So this is a 04 error, meaning the battery is low. If we switch the AC on, we will definitely get power supply to charge the battery also and give an output. Are we ready to switch the AC on? Of course not, because we need to also cover this. So we have already connected the PV. Those are the main connections: PV, battery, AC output, AC input. So let us cover this before we can activate this inverter using AC. All right. Top bosses, if you are finding value out of our today's video, kindly smash that like button. So again, another important feature is to ensure that you switch off the inverter before you can operate it, or you can open it. So let us first connect that. Kindly go and switch it on. Top bosses, if you are finding value from our today's topic, smash the like button. So once, my top boss, you switch AC on, from this you can see that it has already turned on, and then the inverter also has this on the screen indicating that indeed AC is on. So this is sort of a tower. This is what you normally see from the national electricity grid, this tower, meaning the AC is on. And the AC directly feeds the load. That is why you see an emoji for a bulb right there. But again, you can see that this is a box indicating AC, being fed AC. And then the other half of this box is DC, meaning after the conversion, because remember the primary purpose of an inverter is to convert DC to AC. So we have the incoming as AC, turns it to DC because we need to charge the battery. The only way you can charge a battery is if that power is turned or converted from AC to DC because the battery requires DC or direct current. Again, my top boss, when it is on the solar side, it is definitely DC. DC coming from the solar panels goes all the way to DC, which charges the battery. Interestingly to note is that from the AC, the incoming AC can directly supply to the loads. We have any questions?
Yes.
Yeah.
Someone is has turbo. Turbo. Yes.
Tabo.
Yes.
Tabo, good to see you. Thank you so much for joining.
And watching from Zambia,
Mhm.
we love to know how to do a full installation.
For solar?
Yes.
All right.
Then another, the same one person is saying, so
Yeah.
how do we connect to the grid
Yes.
and safety devices from the AC input and output?
Okay. So from the national grid, right?
Mm.
Electricity grid. The basic safety precautions when it comes to connecting the inverter from the national grid is very simple. First of all, ensure that you protect it against a surge. How do you do it? You simply connect a surge diverter in that circuit. So what we do have here is a surge diverter. This is a two-pole or a double-pole surge diverter. With this double pole, you will simply connect it in the meter box, or another option is to connect it at the consumer unit so that every power incoming from the national grid will have to pass through this surge diverter, so that you also protect the system, whether it is serving you as a backup or it is a system integrated with your home system. It is definitely protected from any surges, either from the national grid or from anywhere within the system that is before the inverter. It could be the generator as well. Now, from there, another important aspect is definitely this. This is what we refer to as an AVS, an automatic voltage switcher. It is simply a switch and it monitors the incoming voltage. It should not be less or more than the required. For us here in Kenya, this inverter has to be fed 230 volts, which is AC. Anything way below that can cause the inverter to misbehave or damage it. Anything more, way above 230, can also damage the inverter. All right. So this one monitors the voltage that is incoming. Is it below 220 volts AC, or is it more than that in, let's say, 300 volts? That can be disastrous to this inverter. All right. So those are the important devices that are required there. Have I answered this question? Any other question? Probably to add on that, there are also other devices that are supposed to be connected from the PV to this important inverter right here. First, we have again a surge diverter. Very different from this one. A surge diverter, which is referred to as DC surge diverter. So this one is AC, connected on the AC side, feeding voltage or power to the inverter, isn't it? And then from the solar panels, we definitely have the DC surge diverters, which are connected between the solar panels and the inverter, or even the charge controller. If the inverter does not have an inbuilt MPPT, it will definitely be connected to a charge controller MPPT. And we insist on an MPPT if we are using a lithium battery. All right. Yeah. Another protective device apart from a surge diverter is definitely a DC circuit breaker. So this one is an AC circuit breaker, but we add a DC circuit breaker, which is connected between the solar panels and the charge controller, or the solar panel and the inverter. So DC, SPD, DC, MCB, and we also have DC MCB, right? DC MCB. So those are three important features which are usually connected between the solar panels and the charge controller or even the inverter, right? DC MCB, DC double pole MCB, DC SPD or DC surge protective device. Because again, my top boss, remember, there could be surges from the solar panels. Where can these surges come from? Assuming lightning strikes on the solar panels, they are definitely capped by the SPD on the DC side. And remember, there has to be proper earthing on the solar side. Now, this is where many electricians make a mistake. You must ensure that you earth your solar panels. No question about it. Majority of the people just think that DC is only about two cables, which is positive and negative. You must provide a pathway for earthing for the solar panels. In case lightning strikes on these panels, they will definitely be redirected to the ground instead of the DC system, be it the charge controller or the inverter, damaging either of those components. So you have to ensure that you create a path for earthing. Very nice. Any other question? None. Now, from there, my top boss, before we end the stream, do you have any questions? We have installed a 1 kilowatt inverter. In the next video, we will be talking much more when it comes to 3 kilowatt as well as the most common system that is used in homes, which is 5 or 6 kilowatt inverter. Will you want us to connect it from stage 1 or step 1 all the way to the last step? We will also be guiding you more on that, my top boss. Also sharing the components, also elaborating why you need the various components in that system. And you will definitely learn a lot, my top boss. Subscribe to our channel if you have not. And if you like this stream, or if you will be watching this stream as a recorded version, let us know whether there is a topic that you would like us to touch, my top boss, and also hit that like button. So my top bosses, we thank you so much for watching our stream, taking part in the comment section as well as on the chats. Thank you so much, my top bosses. I will also appreciate if we continue engaging. If you are looking forward to grow in terms of the solar knowledge, we have a course that is ready where you will learn how to install, be it gel batteries, be it lithium batteries or lead acid batteries, be it a 1 kilowatt, be it a 3 kilowatt or a 5 kilowatt battery, and also the type of solar panels. If the solar panels are connected in series or parallel, how will you know? How will you know a system that requires parallel connection or series connection? Now, my top boss, before I go, let me leave you with this question. If I had 2 solar panels, each solar panel gives 12 volts output, and I want to connect them to give 24 volts output, is that a series connection or is it a parallel connection? Top boss, in the comment section, let me know the answer. My top boss, I really do appreciate your time with me. My name is John Gatehi, and I have special thanks to our top boss Margaret, who has been assisting us on the chats, and also special thanks to our director, the one and only director Lee. Thank you so much for being here, and also special thanks to you, my top boss, for watching us in today's stream. It has been a great honor having your presence. My name is John Gatei, and this is Heights Electricals and Electricians. Goodbye for now.